Okay, so any questions before we start? Yeah, good morning.
Yes, sir. I had a question regarding the chapter 2.
Mm.
Among the questions for the study plan, at the end of this class, if you have time, I would like to have some explanations regarding that question. It's about the diagrams, like the graphs.
Yeah, so it's chapter 2. Okay, I think it's best if you ask it during office hours, since we're in chapter 3, or yeah, or maybe just after the class. Yeah, so, yeah, actually, I shouldn't ask any questions. We should just start because we have much to see today. So let's go ahead. Sorry for not answering. I just realized it's not a great idea to do that at the beginning. Okay. So, where were we? The demanded price. Yes, we've seen that.
I believe we were at chapter 4.
Oh, yeah, I think, do I have, oh, I have the wrong chapter. Sorry. Oh, all right. 1 second. Yeah, I was like, yeah, it seems like everything is was already done. Yeah, okay, I have it.
I just wanted to confirm that chapters 1 to 5 are coming for the midterm exam, right?
Oh, I haven't checked that, but yeah,
Because
if that's what written.
In the course outline, it's written chapters 1 to 5.
All right.
Okay.
If that's what written, then that's what it is.
Okay, thank you.
Okay, so. All right. So here we were. Okay, yeah. So there was this big question about the sign of the elasticity. What should we do about it? So I've checked the kind of questions that they are going to ask you in the labs, because that's, that's what. So first of all, this equation is true. Okay, so that's our starting point. And what do I mean by any variable? If I have delta x so if I have delta x means x x1 minus x0. Okay, so delta x means the change of x. So here I have change of q, so q after minus q start, and here I have change of p after minus p start. So since there is a inverse correlation between the quantity that people are going to buy and the price, then the elasticity is always negative. So how does that square with what we have later? Yeah, so how does that square with what they're giving us here? Here they're saying, oh, but now we can just flip the sign, no problem. Well, I think that what they had in mind is we don't want to confuse anybody. so we're just going to make sure that the elasticity is always positive. So I don't think it's a good idea, because I think it's, first of all, it's confusing to anybody who knows one or two things about math. And anyways, it's, it's not helpful. You need to know what the definition is. So the elasticity is, if there's an increase in price, then there's a decrease in quantity demand. So that's what it is. So I'm not going to change it for you. And if you want to express it in absolute value, if in magnitude, or if you don't care about the sign, then you have to know that what you're doing is taking absolute values of the elasticity. So here, the absolute value of minus 0.125. So we just write it between vertical bars. So that means basically if the sign here is positive, nothing changes. And if there's a minus sign, then the minus disappears. That's the definition of taking the absolute value. And now I'm just going to finish this, and then I take your question. So now what do you do in the exercises? Are they going to be, what are they going to ask you? So I've checked, and there is one exercise in which they ask you, please compute change in price, change in quantity, change in percentage bought, and then elasticity. And then they specifically say, by the way, do not write any minus signs there. And I thought it was a bit ambiguous, because I didn't know if the minus sign only applied to the elasticities or to everything. And I've realized it applies to everything that they are asking. So I can't remember what question it is, but please do the practice questions and you'll see what I mean. So when they write, don't write negative signs, just don't write negative signs. But know that the elasticity, if it's elasticity of demand, since people don't want to pay a lot of money, then the elasticity of demand is negative. Then when we talk about it, we say, oh, high elasticity or a low elasticity, then we always talk about the absolute value. So when we say something is very elastic, we mean that the elasticity in absolute value is like very large, like 4 or 10 or something. And inelastic means close to 0. All right, so that's what I wanted to say. Yes, go ahead.
You just answered my question. Thank you.
All right, yeah, I thought that might be the case.
I have a question.
Yes.
So that means if in the labs they say don't put the negative sign, we're gonna have to write it with the absolute value, right?
Yes. And so what I'm saying is there was something like write the changes and then write the so next question, write the elasticities. And then they say, so do not write negative signs. So at first I thought, okay, so that applies to write elasticities, but no. So it applies to changes as well. And of course the changes are negative. Here you see that, well, actually here, yeah, so the change is different. Yeah, so anyways, no matter what this mean, what this example is. So when they say don't write negative sign, it applies to like everything in the exercise from what I've seen. Okay. All right, so here we were. So this is perfectly inelastic. So to know when it's perfectly inelastic, then you look, okay, here I have quantity. So inelastic means I don't change the quantity. So Here it's a perfectly straight bar, so no matter what the price is, I always demand the same quantity. And perfectly elastic means that I can demand whatever quantity I like. So of course, if the price changes by a small value, then I change completely the quantity I demand. And this is a unit elasticity. So this we had seen at the end of last class. Okay, so yeah, what determines the elasticity of demand? So if products are close substitute, then they have elastic demand. So somebody has an example of that?
Pepsi and Coca-Cola.
Yeah, great example.
What is a close substitute?
A close substitute means that it's very easy for people to pick one or pick the other, and they're mostly the same for them. So another example would be Naya water versus crystalline water. Maybe that's these companies don't exist anymore. I don't know. Maybe it shows my age. I don't know. So those are two water brands. Yeah, and water is water. So this means that if Naya water is a buck and crystalline water is a buck, and then for some reason they decide to sell Naya water for $1.50, well, if I can get exactly the same or very, very close to the same at $1, then I'm just going to pick the $1 bottle, so water. So that's what it means to be close substitute. Yeah, so products with no close substitute tend to have inelastic demand. What you would say is something like
maybe electricity.
Yeah, electricity. Very good. Or yeah, oil. Why? Well, because so much is relying on this. So it's very hard for me to say, oh, price of electricity goes up, then no worry, I'm just going to use everything fueled by oil lamp or something. So it's electricity, so there's no substitute for it, basically. Oil, again, you could try to use an electric car, you could try to, yeah, we could, but electric planes, it's more difficult. And then this, I'm saying electricity in general or oil in general. But if I'm saying something like Canadian oil versus American oil, so where do I put that? I put that here. So example. So here I'm not saying substituting oil. I'm saying, oh, if I'm buying oil from Canada, from the US, then these are close substitute. So because they're, well, I don't know how close they are, but if you have a good pipeline from one place or the other, or if you bring your oil by train, then bring the oil from the west of Canada or bring the oil from the US. At some point, oil is oil. So if one becomes cheaper than the other, then I pick one or the other. So you really see that you have to be precise when it's not like, oh, the definition of one good is it has a large or small elasticity of demand. Everything depends on the context. And yet this is exactly the case. So narrowly defined products have more elastic demands than do more broadly defined products. So here, broadly defined is oil. So I could say, for instance, apple versus oranges, broad products. But Pink Lady apple versus Cortland apple, Lobo apple. It's easier to write.
I have a question.
Sorry, so I have a question.
Oh,
Go ahead.
Yeah, when we talk about broad products, what do you want to mean?
Yeah, so broad would be the whole set of all apples. So substituting apples for something. If I want an apple pie, I have to buy some apple. So I can't substitute oranges or else I'm getting an orange pie. But then if I have to pick between certain brand of apple, well, if there's no Pink Lady apple, I'm going to use Lobo apple. It's not that bad.
I have a question as well.
Yeah.
Say you have like a product, and then instead of buying it from the seller, you buy it from the producer, but you buy it in bulk. Would that be like kind of like the first example or no?
In a way, it's so what you would say is, so it's you're not talking about the specific product having substitute or not, but the way you buy it.
Yeah.
So you would say something like, oh, if going to the store becomes inconvenient, well, I can substitute going to the store by going to the farmer and buying it from there. So
Okay.
all right. Importance in the consumer's budget. This I've found it a bit confusing when I saw that first. It depends exactly on the interpretation you have. So I think so I've read the book, and this is how my take on it. So projects that represent a small fraction of consumers' budget tend to have less elastic demand. So what do they mean by that? I think what they mean is it's so cheap. You don't think about it. Example, sugar or salt. So, if sugar becomes 10%, 20% more expensive, I never check the price of sugar. Well, maybe I can check one brand, but at some point I'm just going to buy sugar. So it's or salt, because it's cheap. So it's something that you always use. Whereas if it's something like, I don't know, buying a house, then if it's 10, 20, 30% more expensive, then I think about it a lot before I buy it. So I think it's in this sense. And then, yeah, products that represent a large fraction of consumers' budget tend to have a higher elasticity of demand. So again, this is, I could pick any brand of sugar. Maybe something is a bit more expensive or not. I don't really care. But if it's a house that costs 10% more, I'll consider it a lot. So because it's such a big part of my expenditure for 10 years to come, for my to pay, so I really care about it. So I shop a lot. That's what I think. That's the interpretation. But you could also think something else, but housing in general. Not elastic. What does that mean? What means if you are studying in Montreal and rent goes up everywhere because there's a crisis of housing in Montreal, for instance, well, you bite the bullet and you pay more for your housing. So you have to have a house. This is for between one house and the other. So it's a subtle point. Yeah, and higher price elasticity for more expensive items. That's for sure. So somebody get this thing. It's sort. I wouldn't go normally into such detail, but that's what they're saying there. So that's my interpretation of it. All right. Short run, long run. The response to a price change will be greater in the long run than in the short run. Why?
People will have time to adapt to the change.
Yes. So example. So if price of gas goes up, then in the short run, I have to use my car. Long run, I can change car. So that makes a much intuitive sense. So this is again a real testament to how economics is complicated and subtle and depends on the situation. So you cannot even say, oh yeah, the price elasticity of gas is 2 or is 0.5. No, it always depends on the context where you're measuring it. What is the time interval to measure it? If it's an increase of gas now, and then also it depends on how much people expect that this change is going to last forever. So if they know that there's a spike in price, oil price today, but it's going to go back down tomorrow, then they might. Well, actually, now that I think about it, if the price is really temporary and I still have gas in my tank, then I know, oh, I'm better not buy it today, wait tomorrow. So in that case, it would be super elastic in terms of people buying it, because if everybody knows that they just have to wait a few hours so they can again buy it at the low price, then nobody's going to buy it. So it would be like a infinite price elasticity. So yeah, no matter what the situation is, you have to think carefully and to argue your point. All right, so that's time. So people get this thing, no question.
I have a question though. I'm still confused a little bit. When you talk about short run, is it regarding the demand of the product or?
Sorry, I didn't get the first half of your
When you
question.
talk about short run, is it relatable to the demand of the product? I don't understand. Short run, long run.
Short run is sorry. short time period, time interval. So say for instance 1 day, and long run would be a long time interval. 1 month, for instance. So of course, I'm not saying the definition of short is day and the definition of long is month. I'm saying if you compare, so this is a short run and this is long run compared to that. Yeah, so if I know that there's a crisis, there's a war somewhere in the Middle East, and the price of oil is going to be high for a very long period of time, then I think, oh, let's try to go to take the bus or take a bicycle or use some other means of transportation. Right. So then what does that look on the graph? Well, it looks like from the starting point here, I can ask what is the short run demand or the long run demand. Short run demand is going to look much more vertical because I don't have time to adjust. So whatever the price change is, then few people are going to be able to change their behavior. But long run demand might look more flat because then people in the long run will be much more able to buy something else, go live somewhere else, take some other means of transportation. So the quantity of the amount of gas that people are going to buy will be able to change much more. And initially I told you it's a static thing. Well, here it's really not a static thing. You can really draw arrows. So you can say that, imagine we start here, and then there's a shift in supply. So for instance, I don't know, it costs the cost of oil goes down. So then you go to the pump, and I know it's not realistic. Normally the price of oil goes up all the time, but imagine that gas is cheaper for a while. So what happens in the short run? I'm just going to zoom in to draw my thing. So in the short run, I follow the short run demand, and the equilibrium is going to move here. But so that's in the short run. In the short run, the price is going to go down a lot, and the quantity sold is not going to change a lot. So that's not that good for gas stations, because that gas station, they just sell the same quantity at a lower price, so they make less profits. But then if you just wait, say after a month, then after a month, people say, oh, then I know that gas is going to be cheap for a while, so I'm happy. So let's buy a SUV and go to take a trip in the US. So then, whoops, quantity of people who start using the product or enter the market increases. So then the price is going to increase again. So we're going to go there. So this is, I'm going to say this is, let's see, green is short run and yellow is long run. Yeah, and how do I know what the market is going to do? I have to measure it. I have to observe some shock in the price of oil. For instance, I don't know, some country discovers new reserves and start exploiting them right away. And then I have to check, okay, so a week later, what is the price, what is the quantity? And then a month later, what is the price, what is the quantity? And I should observe something like this. All right. Okay. Okay, so elasticity and total expenditure. So what is total expenditure? Well, it's the amount of money people spend. And what is it? Well, if there is some equilibrium price and quantity, so here, for instance, then the total expenditure is how much people are buying multiplied by what the price was. So price times quantity. And then there's an interesting question that we can ask is, how does total expenditure change when the price falls? So imagine that so let's start thinking intuitively. So imagine that the price was $1 million for, I don't know, for oil. And then it falls to, let's say $10. So how is that going to affect total expenditure? So you have to think to yourself, okay, the price falls, so the price changes, but the quantity changes too.
So the total expenditure like drops, I mean, also.
The
If
total
price
expenditure doesn't change because it costs less, but people buy more, so it evens out.
Oh, it's true.
Yeah.
Yeah, so you have good ideas in mind, but if I start by a price of $1 million, how many people go to the gas station and buy gas at that price?
Little.
Zero. So then if I decrease from 1 million to 10 million to $10, then I started at 0 customers, and now at least I have some customers. So initially my total expenditure will increase, right? So it's going to start increasing until I get to, well, maybe I should draw a graph actually. Yeah. This is going to be much easier. And I'm going to even draw something beautiful this morning. And imagine that the man looks like this, for instance. So if, and this is total expenditure. So here it's this thing. Here it's this thing. Here it's this thing. I have quantity and I have price. So if the price was not $1 billion, but imagine this is 1,000, then what is total expenditure? It's 0, because it's 0 multiplied by 1 million, but 0, even if 1 million is a big number, 0 is 0, so it's 0. Then price starts to decrease, and then, oh, I get a few customers that are super motivated and buy for a lot of money. And then price decreases more, and then I get even more customers. So here, for instance, the price decreases by say $2, and I double my quantity of people who buy the goods. So that's good. Expenditure is going to increase. And here it's very large. So it's, I don't know, 6 something by 5. So that's a lot of people. And then if I still continue to decrease the price, now I have many customers, but they pay so low that total expenditure is actually starting to decrease at that point. And here, if the price is 0, then I have I'm giving it away for free. So that's great. A lot of people are going to take it, but what's the total expenditure? Well, it's of course 0 too. So that's the interplay between price and quantity. All right, so if demand is elastic, the quantity change dominates and the total revenue rises. So let me draw a graph of that. Here I have, let's see, demand is elastic. So elastic is this way or that way, 1 or 2. This is quantity. This is, yes, it's 2. So elastic demand. So you see that the price just declined by a tiny bit. And I have many more customers. So then the total expenditure or the total, they say revenue. Revenue is for firms. So you would say, so what you imagine is that the expenditure of consumers goes as revenue for firms. So that's why they say revenue. So that's what is happening. And here that's the reverse. So let me draw that right here real quick. So here the demand is very inelastic. So a drop in price, a big drop in price will have little impact on quantity demanded. So then this is the bad part for the gas station or the supplier. So in that case, they don't get to increase their revenue by a lot.
So is there a link with the long run and the inelastic demand?
So yeah, it can be inelastic for any reason here. So maybe it's because this would be long run, this would be short run.
Is there a link with that?
Well, there's a link because in the short run it's more inelastic. So this would be more short run, as we've seen. So let me go back. Yeah, so this is exactly this situation. So short run, you see that there's a big drop in price and a small change in quantity demanded. So that's just a lot of, yeah, probably the total revenue of firms would increase. But then you see what happens in the long run. In the long run, the final drop in price is quite small, and the final increase in quantity is large. So in that case, in the long run, yes, you would have a...
Yeah, it's written. Yeah.
But you know, it can be for any reason. If it's Coca-Cola, Pepsi, or some other thing. So if, for instance, it's the price of oil in general, then well, then if the price goes up or goes down, it just it doesn't translate into a lot of change in demand. So, and now this point here, actually, I don't have enough space to draw it. So, okay, so let me just read it too. If demand is unit elastic, the percentage change in quantity demanded equals the percentage change in price, and the total revenue remains unchanged. So let's try it. So I'm just, this is slide 16, and then I'm going to 17. So I'm going to draw it here just to, because it's, it demands more thing. So this is, it's, again, if I could use calculus and a derivative, then it would just take 30 seconds and everybody would see it. But yeah, now I have to, I'm just going to draw stuff and I'm going to show you what this means here.
Professor?
Yeah.
Could you still explain it using math?
All right, I'll explain it using math just later on.
Thank you.
All right. So if, so imagine this is unit elastic, for instance. It's a 45-degree line, doesn't have to be, but it's simpler to do that. Now I'm, for instance, here. And I go to here. So does that, oh yeah, I can actually count the number of squares. So what I want is to have the same number of squares. So that's, yeah, okay, it works, perfect. All right, so what happened there? If I, so here this was 7 long and it decreased to 5 long. So the price dropped by some, oh, how much? Can somebody compute that for me? Yeah, I'll compute it.
Compute what?
5 divided by 7. Yeah, 7%. About 7%. So here the price dropped by about 7%. And the quantity increased by about 7%. So price 7%, quantity increased 7%. So from this revenue to that revenue, what's the net change?
Zero.
Yes, exactly. Net change in revenue is 0. Or expenditure, let's see. expenditure change.
Would that mean the slope of the line is just 1?
Yeah, but it doesn't have to be. I could have a different slope. Here is just, it's easier for me to do it with the 45-degree line, but I could just squish this graph and it would work. The important thing is that the percentage change of the price is exactly the same as the percentage increase in the quantity. 0%. Whereas here I would have something like, yeah, here the price would double and the quantity would change very little by, say, 1%. Or here the price would change by the quantity would change by a few percent and the price would, say, drop by 50%, for instance. So here at in the middle of my graph, I see that percentage change of price is exactly the same as percentage change of quantity. So the net expenditure change is 0%. And what is the elasticity now? Is delta Q over Q divided by delta P over P. So yeah, and then let me add some. So you see that, of course, if this is plus 7%, and this is minus 7%. So then the elasticity is exactly -1. Oh, I can't grab my line there. So this is what we mean by having a unit elasticity. Since it's a domain elasticity, the unit elasticity is equal to -1. And it's the case because the change in price, -7%, is the same as in proportion as the change in quantity, +7%.
Professor?
Yeah?
Does that mean if you want to find the expenditure change? No, if you want to find eta, you just find the slope of the line.
Yeah, you need the slope of the line and you need to know where you are, actually. You need to know P and Q as well.
Okay.
And now I'm going to use math for this. So how do you know it reaches a maximum? So, well, if you just count the squares and you see that, yeah, here it's more or less the maximum. So the maximum number of square would be here 1, 2, 3, 4, 5, 6. So 6 by 6 would be like the maximum. And if you're here, it's not the maximum. And here, so, but for people who know calculus, let me just tell it briefly. So, yeah. So this, don't get scared if you don't understand, but so what do we mean by revenue reaches a maximum when demand is unit elastic? So the revenue is, sorry, yes. Revenue would be P times, so let me have P times Q. So if I want to maximize it, I take the derivative of the revenue equal to 0 simply. So dr divided by dp would be equal to Q plus P times, yeah, let me put the times here. dq.
Sorry,
divided
which example is this for? Which node is this for?
for this point here. So maximizing the revenue. Again, maybe I shouldn't do that, but it's for people who know a bit about calculus. You're going to see it's very easy. So this is equal to 0. So then I'm done basically. So this is what it means to maximize the revenue is I take the first derivative of this and I set it equal to 0. So then I can just rearrange this. So I get that this is equal to minus this. So so let's divide by p. And here I'm going to get rather I'm going to do the opposite. So okay, scratch that. So I'm just going to divide by, so multiply by p and divide by q here. This is going to be equal to -1. And this is, of course, the elasticity. dq over dp times p divided by q, and it's equal to -1. So yeah, don't worry if you don't know calculus. Okay. So yeah, so these were these 3 points, and this is when the demand is elastic, total revenue increases when price falls. So that's when I'm here. So here the total revenue increases when price falls. When it's inelastic, the total revenue decreases when the price falls. So yeah, these things say basically the same as the ones in the previous slide. All right, and here, for those who don't know calculus, this is how you do it. So you just compute it at every possible quantity, and you're going to see that, when the elasticity is eta is about 1, but this is -1. Yeah, so add minuses there. Then when this is the case, this is when the expenditure is at its maximum. So the kind of things that they can ask you is, okay, this is the quantity demanded, this is the expenditure. Now, so price, quantity demanded, then compute the expenditure. And then they say, and then you see that, okay, the expenditure is maximized here. And you can also use these things to compute the elasticity, and you'll see that you get unit elasticity exactly at that point there. Yeah, so so if you know, just apply your definition and remove the minus signs when they ask you to not put minus signs, and you get the right answer.
Can you go back for like 2 seconds?
Yeah.
Thanks.
Sir, I was just wondering, what does unit elasticity mean, like in the situation in life, for example?
Unit elasticity means eta equals -1. Or if it's supply, it's eta equals to 1. Or if you mean in absolute value, then yeah. See, unit elasticity means, oops, that epsilon eta goes to 1. Yeah.
Thank you.
So 1% change in price is reflected by a 1% change in quantity demanded. That's so if you divide one by the other, you get 1. All right. Okay, so that was demand elasticity. Now price elasticity. Oh, by the way, let me... All right. So
I have a question.
Yeah, go ahead.
You said when the expenditure is maximized, what happened to the elasticity?
Well, it's close to unity. It's close to 1 or -1. So that's what they say here. So total revenue reaches a maximum when the demand is unit elastic. So, and this is how you see it. So the demand is close to 1. So what is that? That's expenditure. Yeah, expenditure is maximized, and that is when the demand is unit elastic. So at that point here, when the square is as big as it can get. So to see it really, if you don't know all the math, then just compute, okay, price is 12, quantity demanded is 0, so expenditure is 0. Then price is 10, quantity demanded is 10, 100, and you can really see that you get the maximum 180 here. And that's going to be a point where you have unit elasticity. All right, so supply is exactly the same, just that you're going to naturally get positive values for eta. So here is, yeah, they write eta S for supply elasticity. So that's just the percentage change in quantity supply divided by a percentage change in the price. So delta Q divided by Q divided by delta P over P. So you just computed the same way as you do for price elasticity, basically. So here again, what they are going to ask you is take the average of both points, probably. So you take, so you see that the average quantity was 50 plus 30 divided by 2, for instance.
What's the line above the P and the Q mean there in the formula?
Say that again.
You see how there's like a little line above the Q there? Up, like in the formula.
Yeah.
What does that mean?
Oh yeah, so it's delta Q over. Oh yeah, exactly. Sorry, I see what you're saying. Yeah. This little line here means average.
Okay, I got you.
Yeah, so X mean average. Well, drawing is not that easy. All right. So you just applied your formula and you should be good about it. All right. So what determines supply elasticity? Well, lots of things. So here they just put 1. I don't know why. So how much can be? Yeah. So basically, how much can be? So how can firm react when there's a when there's a change in price? So lots of things. So So I guess if they ask you that's the generic answer you can give them, but get an elastic supply if, for instance, it's easy to change the production volume. So, for instance, hydroelectricity. It's very easy to just let more water pass through the dam so that you generate more electricity. Easy to distribute. So again, electricity is a good example, because it's just the wires are all there. But if it's something that's hard to bring to people's home, for instance, then even if the people want more, then it's not that easy for firms to react to it. Easy to store. So again, hydro is a good example. Because it's just you let the dam fill and or you would see diamonds. So you just have a big reserve of diamonds. So if the price of diamond changes, it's easy to adjust the supply to the market. Yeah, and if it's a global supply, more elastic than local supply. Why? Because global supply, you have so many different countries that can supply you. But if it's a local supply, then you have a few stores. So, but it's not easy for them to magically increase their supply. Yeah, and inelastic is a bit the difference. Just a question about this. So is wind power or wind or solar power? So is it elastic or inelastic?
Inelastic.
It depends.
Elastic?
Yeah, it depends. So yeah, let me put it here. Inelastic in short run. Why? Because you have the installation you have. So if there's no wind today, there's no way for you to produce more electricity. But in the long run, if you know that there's higher demand for electricity, then there's a infinite potential of wind or solar power in the world, so you can always install more. So elastic in the. So you see again that it's so easy to install. Yeah, possible to install more. So again, it depends on the technology, it depends on the market. So yeah, contrary to reverse. So if it's not easy to change production, not easy to distribute, not easy to, this kind of thing. It depends really on the supply aspect of it. And yeah, this goes into my next point. So short run. So supply curve are immediate responder, not too elastic, they're inelastic, because it's not super easy for firms to change their production volume. But in the long run, yes, it's easy for them to expand production, for instance. Again, this is the same sort of graph as before. So, for instance, this would be a change in the short run. So here there's more demand. So imagine there's more demand for electricity. So in the short run, let's put that in green. So that would be short run. Oops. So it's not easy to increase the amount of production because I don't have solar panels, I don't have any more. But in the long run, I can install more solar panels. So the price would go up a lot. But then in the long run, let me put that in yellow. Then in the long run, so yeah, let me have. Yeah, so in the short run, I'm able to expand, so the price can go back down because the supply is going to match the demand. Okay, so last point before the end. Actually, I wish I had more time to talk more about this, but here we go. I'm let you think about it more at home later on. So if I'm the government and I want to say tax gas because I want to limit the greenhouse effects, so I put a tax on gasoline. Should I tax the consumers after they fill in the tank, so at the gas station, or should I tax petroleum companies? So is it
petroleum companies?
Petroleum companies? Who is
No,
so? Do you
Isn't it
do
better
most
to tax the consumers?
better to tax the consumers?
Yeah, so because they're the ones that are going to get hit.
Yeah, so the consumers are going to get it. So what if I tax the petroleum companies, or am I going to hit them or not?
Prices will increase, but maybe consumers will assume that, oh, the price of oil just increased. It wasn't a tax. Maybe
Okay, so
they wouldn't think much of it.
yeah, so you're saying that anyways, you look at it, consumers always end up paying the tax.
Yeah, higher prices.
Yeah. So do everybody agree with this reasoning mostly, or do I have some?
Yes.
Yeah, I agree. When someone needs to use a car, they can't decide, what's the expense for me. Well, because if their job relies on the car, then they have to pay whatever.
All right. So what also is very, very good. So now you're saying two things. You're saying if I tax the petroleum companies or I tax consumers, it doesn't matter. The consumers pay, but then you're saying, why do they always pay? It's because they don't have any choice to use their car. So I would say that it's 100% right. But so that's true because consumers don't have any choice. But imagine that consumers have, so we have very good electric cars, and now you really can choose whether you buy electric car or not. Then if I increase the tax for, say, consumers, so would they pay most of it, or would petroleum companies take a hit too?
Oh, people would
They would
start
take a hit.
switching. Go ahead.
Yeah, exactly. So it's awesome how good your intuition is. Really, I've taught economics in Europe, and but they can be very smart, but it's very difficult to explain economics to them. So yeah, you understand perfectly. So here it is. Yeah, so that's very funny actually. Excess tax. Yeah, the price paid by consumer. Okay. All right. So here, the tax is paid. So I'm going to write it here. Here, the tax paid by producers. Okay. So how do I see that? Well, so that's a tax. So this was the old market equilibrium. And now I ask the producers, okay, for every unit you sell, you have to pay a certain amount of tax equal to PC minus PS, okay? This distance here, that's a unit tax, we call it. What happens? Well, if I'm a producer and I know that if I receive a price of $10 from the consumer, but I get to pay $10 extra for the government, then well, I'm going to ask not $10 but $20 to the consumer. I'm going to tell the consumer, oh, but I want to break even here, so I know that $10 was my best offer I could make you. Now the government is asking me, pay me $10 more. So I'm going to go bankrupt if I pay the government the same amount of money before. I received the $10 from the consumer, but I have to pay it to the government, then I don't make any money. So you see that imposing a tax on the supplier will shift the supply curve up. So it's exactly the same as if the supplier had an extra cost that they needed to pay. So if if the wage of their employee increases, then they have to charge higher prices and produce less. So it's the same for them. It's an extra cost that they need to pay. They need to pay it to the government. So their supply curve goes up. But you see that it doesn't mean that the consumers now they pay all this extra tax. Where is the new equilibrium? The new equilibrium is here when the new supply curve crosses the same demand. And you see that the new equilibrium is going to be E1 here. Well, and you're going to get a gap between what the consumers pay, PC, and what the producers get, PS. And what is this gap? It's the tax that they pay. All right. And I'm going to show you that it's exactly the same if I charge, instead of charging the producers, I charge the consumers.
So this means that the consumers will take the entirety of the tax because they will pay the normal price plus the price of the tax, right?
So to know who pays the tax, you have to compare what was the price before the tax. It was P0. And then what happened? Well, the price paid by consumer increased, but the price received by suppliers decreased.
So in this case, they both pay evenly.
Yes, exactly. In this case, they both pay the same fraction of the tax as before. Consumers are less happy because prices went up. Suppliers are less happy because revenue went down. And what happened? Well, in between, there's this chunk of money that neither of them get or pays. That one pays and the other doesn't get because that's going to the government.
And is it possible for a producer to stay to put all of the tax on the consumers?
Yes, and we're going to see that next if we have time, but I think, yeah, we're out of time. So let me give me 1 minute, and I'm just going to show you what happens if we do the opposite. Oh yeah, actually, yeah, I think I'm just going to copy the graph. It's going to be easier.
Could it be said that when demand is elastic, the consumers pay the tax, and when it's inelastic, the producers pay the tax?
Yes, exactly. Oh, Jesus.
Can you repeat that, please?
Sorry, I have to concentrate. Oh my God. H. Okay, good. So what I said is, is it possible for the suppliers to put all of the tax on the consumers? Yes, if the suppliers have an infinitely elastic supply curve and the consumers don't have an infinite supply. So here I just copied that. And here, if the tax is paid by the consumers instead of the supplier, what happens? Well, now the consumers were saying, oh, I'm ready to pay, to consume this quantity Q, I would be ready to pay this, but now I know I have this extra tax to pay. So actually, I just want to pay this much to the supplier because I know that the rest I have to pay to the government. So then the new supply looks like this. And the new equilibrium is here. So what changed? Well, now the consumers, they pay this much actually, but then the government takes a chunk of it, and the suppliers, they receive a very low price. So it's exactly the same situation as before. So in here, yeah. Yeah, so it's exactly symmetrical. So there is one difference. Here, the market price is high, and this is what the government, so what the supplier get after tax. Here, the market price is low, but this is what the consumers feel that they're paying because they are paying this extra tax. So the consumer, for them, it's expensive because there's this extra tax that they pay after they bought the item, and the market price is low. So the only difference is the market price, but that's nominal because what everybody gets, if it's consumers or the producers, then it's exactly the same in both situations. Okay, so we're out of time. Think about this for next question.
In this situation, it's the same as before, right? The consumers pay more and the suppliers get less.
Yes, exactly the same. So if you compare, this P0 was what it was before. PC is what PC is the price that the consumers end up paying because they pay for the price plus they pay for the tax, so they pay a lot. And PS is what the supplier end up receiving. They receive much lower because here the market price is low. So I can write here market price. And here the market price high. That's the only difference. So my experience is taxes are complicated, and it messes with your mind a bit. So yeah, I'm going to put this here. So think about it tonight and tomorrow, and then yeah, then we can go back to this example, and I'm going to show you actually what matters. And yes, it's the relative elasticity of both supply and demand that matters. Okay, so finishing here now because we're out of time.
Question, sir.
Yeah.
What is the format of the exam that's coming up?
Oh, it looks very much like the MyLab exercises.
MyLab? Okay, perfect. Thank you.
Sir, can you go ahead with the question for the labs, the chapter 2?
Yeah. Yes. Okay, so everybody, goodbye, thank you. And now I'm going to answer specific questions of people. Oh, how many people are left now? Oh, just okay, so not a lot, or no, a lot of people. Okay, so I don't know, maybe I could stop the class now and just go back to, so let me stop the class, and then in 15 seconds we start. I'm going to answer some extra questions for you.
What do you mean? I don't understand. Like, you want me
just
to...
because I don't want to record this after. Stop recording.
Okay. So
just hop in 15 seconds later. Okay, so ending the class, 5, 4, 3, 2, 1, 0.